Good morning, students. This is next chapter, that is structure of atom. This chapter already came in 9th class. Here we have to discuss so many points along with those topics. Here the first topic is Bohr's atomic model. This theory was discovered by Niels Bohr. He said some points, nothing but postulates. They are, see, this is nucleus, these are shells, these circular parts are called shells. Electrons revolves in these circular parts, that is why these are called shells. All these are present in atom. All these are present in an atom. So the postulate's first point is the electrons revolves around circular parts. This is nucleus. This center part is called nucleus. It contains neutrons and protons. Neutrons having chargeless and protons having positive charge. That is why nucleus having positive charge. Electrons present outside of the nucleus. So what he said, the first point is the electrons revolves around the nucleus in circular paths. In circular paths are called shells or orbits. Those are also called energy levels. That means these are these circular paths. These circular paths are called shells or orbits or energy levels. That is the first point. Second point, these orbits are represented by, that means this is the first orbit, this is represented by K, this is second orbit, this is represented by L, this is third orbit, this is represented by M, this is fourth orbit, this is represented by N. So what is the point? These orbits are represented by K, L, M, N and so on. Why we should say so on? Because that atom contains so many orbits. Infinite orbits are there in any atom. That is why we should say like that. K, L, M, N, so on. ORR. 1, 2, 3, 4. That means this is the first shell, this is the second shell, this is the third shell, this is the fourth shell. 1, 2, 3, 4, so on. The orbits are represented by K, L, M, N, so on. ORR 1, 2, 3, 4, so on. That is the second point. Next point, when the electrons revolves in these orbits, suppose when the electron present in first orbit, then the electron when the electron revolves in this orbit, it never gains energy from other orbit or it never loses energy to other orbit. That means those electrons never gain energy and never lose energy. That is why these orbits are called stationary orbits. Stationary orbits. That is the third point. When the electrons revolves in these orbits, they don't lose energy or they don't gain energy. So that these orbits are called stationary orbits. That is the third point. Next point. When the electrons jumps from lower orbit to higher orbit. See, compared to this one, this is lower orbit. When the electrons jumps from this orbit to this orbit, then energy is absorbed by the electron. I repeat once again, listen carefully. When the electron jumps from lower orbit, this is lower first orbit, this is second orbit, so automatically this will be lower, this will be higher. Come among these two. Among these two, this is second, this is third. So this will be lower, this will be higher. Among these two, this will be lower, this will be higher. So what is the point here? When the electrons jumps from lower orbit to higher orbit, then energy is absorbed by the electron. When the electron jumps from higher orbit to lower orbit, then energy is released. When the electrons jumps from lower to higher, then energy is absorbed. When the electrons jumps from higher to lower, then the energy is released. This is the fourth point. And the last point, that is the angular momentum. Angular momentum. Angular momentum, this is represented by mvr. Actually, the formula for angular momentum is product of moment of inertia, that is represented by I, into angular velocity. The product of moment of inertia and angular velocity. The product of moment of inertia and angular velocity is called angular momentum. Where the formula for again moment of inertia is mr square. This is the formula for moment of inertia, into the formula for angular velocity. This is the angular velocity is v by r. This r will become cancelled, then finally we get mvr. Actually, this moment of inertia angular velocity formulas comes in physics. So here you no need to remember the formulas regarding moment of inertia and angular velocity. You just remember this one, angular momentum, nothing but mvr. So here the last point is the angular momentum of an electron is integral multiple of h by 2 pi. That is angular momentum mvr is equal to n into h by 2 pi, where n is integral multiple of h by 2 pi, nothing but n into h by 2 pi. That means what? Suppose when electron revolves in this orbit, that means in first orbit, then angular momentum mvr is equal to 1 into h by 2 pi. Suppose when electrons revolves in second orbit, then this is first orbit. When an electron revolves in second orbit, then angular momentum 2 into h by 2 pi. When electron revolves in third orbit, then angular momentum is 3 into h by 2 pi. So this is in second orbit angular momentum, this is in third orbit angular momentum. That means what? This h by 2 pi is common. It is also having some fixed value. I tell you later what is the value of h by 2 pi. But what you have to learn, its angular momentum is always equal to integral multiple. That means integer into h by 2 pi. That is the meaning of that one. So these are the postulates of Bohr's atomic model. I tell you once again, listen carefully. First postulate is the electrons revolves around the nucleus in circular paths are called shells or orbits or energy levels. These are represented by K, L, M, and R. 1, 2, 3, 4. Next, when the electrons revolves in these orbits, they never lose or they never gain energy. That is why these are called stationary orbits. Next point, when the electrons jumps from lower energy level to higher energy level, then energy is absorbed. But when the electrons jumps from higher energy level to lower energy level, then energy is released. Next, the angular momentum of an electron is equal to integer into h by 2 pi, nothing but integral multiple of h by 2 pi, where m is mass of electron, v is velocity of electron, r is radius of the orbit, and h is the Planck's constant. Its value is 6.6 into 10 to the power of minus 27 x into seconds. In joules, 6.6 into 10 to the power of minus 34 joules into seconds. Next, pi value we know that 22 by 7, nothing but 3.14. So these are the points regarding Bohr's atomic model. Next, here one more important topic is there, that is hydrogen spectrum. Hydrogen spectrum, that means when we take hydrogen atom, then we get spectrum. In that spectrum some points are there, we have to discuss those points. Before that we should discuss one point, how hydrogen spectrum will form. See, listen, when hydrogen gas is taken in one tube, and hydrogen gas is taken in one discharge tube, when we heat that discharge tube, then hydrogen gas contains hydrogen molecules, that means H2 molecules. Then those molecules undergo dissociation. Why they undergo dissociation? Because we are applying heat. When they undergo dissociation, then hydrogen atoms will be formed. In those hydrogen atoms, electrons present, means each hydrogen contains one electron. Then that electron gains energy. What I told you, when the electron gains energy, that electron jumps from lower orbit to higher orbit. But at a higher orbit, the energy of the electron is high, but its stability is very less. Due to less stability, the electron again de-excitation, nothing but the electron jumps from higher orbit to lower orbit, higher orbit to lower orbit. Then finally electron gets stability. In such process spectrum will obtain. How spectrum will obtain? When electron jumps from higher orbit to lower orbit, those electrons releases energy in the form of radiations. When those radiations is passed through spectrum, then we get spectral lines. Then finally hydrogen spectrum will obtain. I will discuss this point once again. Listen carefully. We have to discuss here hydrogen spectrum. When hydrogen gas is taken in discharge tube, when we heat that hydrogen gas, then that hydrogen gas contains hydrogen molecules. Those molecules undergo dissociation because we are heating. Then hydrogen atoms will form. Then the electrons present in hydrogen atom gains that energy, and they jumps from lower energy orbit to higher energy orbit. But at higher energy orbit, the energy of the electron is more, but stability is less. Here you have to remember one point, both energy and stability having inversely relation. So that electron now having more energy, that means it is having less stable. To get a stability, the electron jumps from higher orbit to its original position, that nothing but lower orbit. Now the electron gains its stability. In such process, spectrum will obtain. How? Because when the electron jumps from higher orbit to lower orbit, the electron releases energy. When this energy is passed through the spectrum, then we get spectral lines. That spectral lines is called hydrogen spectrum. See, that is like this. This is hydrogen spectrum. See, this is first orbit, second orbit, third orbit, fourth orbit, fifth, sixth, seventh, eighth, like that. Infinite orbits are there, I told you already. But why I have written here orbits in horizontal manner? Actually orbits are always in circular manner, that means like this. But here for understanding purpose, we used to write every time horizontal manner. See, this is first orbit. Actually in hydrogen atom, electron present in first orbit. When this electron gains energy, automatically it gains energy and it jumps from either first orbit to second orbit, or first orbit to third orbit, or first orbit to fourth orbit, anything. Again that electron comes to its original position. In that process, energy is liberated When that energy is passed through the spectrum, then we get spectral lines. These are spectral lines. This is called hydrogen spectrum.